So have you ever wondered where planes fly, how high, or rockets, or where is the International Space Station? Because yes, it is technically into space, but it's still close enough to orbit the Earth. So that's what we're going to talk about today. We're going to talk about these different layers of the atmosphere: the troposphere, the stratosphere, the mesosphere, the thermosphere, the exosphere. And each one is a different properties to it, different sort of sizes. The one that we live in is the troposphere. It has like 75% of the atmosphere's mass. It's where weather occurs. This is where we would find air balloons, we would find planes. More the Cessnas for sure are flying here. Passenger planes actually would be found probably up in the stratosphere, but the lower part of it. So in the stratosphere, this is where we can get our jet fighters. They can go a little bit farther up, but most of the big planes fly in here. We also find something called the ozone layer. It should have an E on this graphic here, but that is the layer that was really important to us. It blocks all the harmful UV radiation. If we didn't have it, we would be in big trouble. Skin cancer would be, everyone would have it. We wouldn't survive. It is something that we do need to take care of. Then the next level up here is the mesosphere. This in the mesosphere is where most of this debris from space ends up because it's a little thicker. It has some molecules in it. It burns up the meteors that are entering our atmosphere. So most things burn up before they hit the Earth right here by the time they get through the mesosphere. Above that then is the thermosphere. And this is where we find the International Space Station. This is where you would see the northern lights of the aurora borealis. If you've seen the movie Frozen, they have that in that one pretty well. We would also find what we would call LEO, or low Earth orbiting satellites. This is where most of the stuff that is orbiting the Earth in the thermosphere. And then we have the exosphere, which does have plenty of satellites. This is the air is really, really thin. Some of it starts to escape because it's, the particles are so small because of gravity, they got kind of pulled out there. Again, this is where we do find some other military, especially probably different satellites out there. And then beyond that is space, and this is where there are no molecules. It is just considered a vacuum, and that's why once it sort of escapes the exosphere, it just, Newton's laws kick in perfectly. An object in motion stays in motion, and so that's why if we're able to escape it, we just keep going straight from where we were. Talking about space junk, that's another thing because we have so many of these different satellites, and so satellites obviously orbit, but there's junk. Now, we track junk that I think is 10 centimeters, or roughly the size of a baseball. We do track that, and you're going to watch a video on that here very briefly. I'm not going to play much more of this video, but as you see here, the closer we get to Earth, there's more junk around it. I realize that it's not high quality video here, but this is closer to the Earth's orbit. We do have a lot of junk. Now, you might think a paint chip is not a big deal, but a paint chip going, 47,000 meters per second orbiting, because that's sort of the orbiting speed around the Earth. If it slams into something, it can cause damage. So you're going to go ahead and watch a video next. After the video, and you answer the questions that go with it, you're done for the day. Get her done.